So I'm super happy to be here. My presentation is called Environments as Cattle. We'll be talking about the cost of non-prod downtime, shifting left, how to do that, and what we mean by the cattle portion of these environments. And then we'll talk about some opportunities that we are going to be unlocking. I want to first start with this quote from the State of DevOps from Google of 2019. They said, productivity can drive improvements in work-life balance and reductions in burnout. And organizations can make smart investments to support it. A lot of what this talk is going to help you do is put a value on doing this engineering. So with our keynote, Randall had talked quite a bit about the CDK. That's a lot of the how. I'm going to try and focus a lot on the why and how to get that as a community inside your organization to take to actually invest in it, so that your work-life balance, your burnout is much less or greater if you have work-life balance. So a little bit about myself. My name is DeJonghe. I'm from Ann Arbor, Michigan. I work for a consulting company called Right Brain Networks. I've been with them for about 7 years, and I run the cloud architecture team. I've done a ton of migrations. I think it's somewhere in the number of hundreds, from small startups with very interesting technology, streaming, stuff like that, all the way up to the Fortune 5s and stuff like that. I've written a few books. I am kind of an Nginx fanboy, so you can see that I wrote the Nginx cookbook, did a 2019 update on that. I'm currently working on the 2020 update, load balancing in the cloud, which is a lot about different patterns and things to this effect. And then the Nginx unit cookbook as well. Also did a 2020 update on that, so that should be coming soon. Unit's a really cool application server if you guys haven't checked it out. I'm excited to start using it. I don't really do the Twitter thing much, but I'm pretty active on GitHub. So if you just check out that handle, there's lots of stuff, demonstrations, little quick starts that I've built over the years that I think are pretty interesting. So let's talk about this cost of non-prod downtime. We all think quite a bit about the cost of production downtime, which is customers are upset, this and that. You got to scramble to get things going. But I think there's a lot of value in talking about your dev, test, QA environments and what it costs to have those down. I had a client that was actually able to quantify it and say their dev environment's down about 8 hours a week. So if we have any sort of function here, it's that the number of devs, the number of operations, and the number of QA people that are working on this and or blocked times the number of hours is the amount of lost productivity. So let's say one dev was working on their something, they merged it, they pushed it out to the development environment, it broke, so they're on it. We've got 1-2 ops people trying to help figure out what the issue might be, and then we might have 3 to 10 QA people that might be blocked. I'm just throwing numbers out there, but multiply that by 8 hours a week, and we've got a full-time, 2 full-time employees. So the cause of non-prod downtime, there can be many, but a couple are untested deployments. And I'm not talking specifically here about untested code, but more so the deployment itself. Do we know that the upgrade from this version to that version is going to work effectively? Are there infrastructure changes that need to go along with it? Have they been deployed in this fashion? I'm talking about actually testing the deployment itself and not just the code. Any manual processes? This one's a given, right? We're all working very hard. I assume if you're in this conference, you're pretty focused on automation at this point. Failed version contracts. So this is what your dev and test environments are really about, right? Integration testing, making sure that this new version works with all the other versions. So API contract versioning is, or API contract version, or API version contracts between different applications is really important. So, if any point those fail, you're going to have a failure in those non-prod environments. Sufficient test coverage, this is just, again, another given. We all try to get to 100% test coverage, and it is a very hard thing to achieve. So sometimes things do have to be tested by QA members and things like that. So there's a lot of manual testing out there from all the different clients I've seen. That's okay, and everybody's working to automate it, but unfortunately, some things get missed. Testing infrastructure changes. So, the dev environments are for testing your code, your integrations between your code, but and a lot of that stuff gets tested and is thoroughly tested by unit and functional tests, and that can happen, in your CI system. But what about your infrastructure? If you've got operations engineers, making changes to your infrastructure for the first time in the development environment, your first environment, then they're testing on what your developers actually see as their main system. So what we'll be talking about is how to help them get to the point where they can build an environment and do their testing on an environment that nobody cares about. That's where our cattle comes in. So the effect of this non-prod downtime is you've got unplanned work, you got your developers' attention, your QA or your operations people's attention, your QA is blocked or idle, and we're spending less time on planned work, which means that we've got delays to our sprints and delays to the roadmap. So when we talk about the cost, it's not just the engineer pay, of the QA members that are sitting around, blocked, or the production, or the planned production of those engineers that are now taken away for this unplanned work, but we're also talking about the sprint and roadmap delays and the cost of what that is. We might delay a feature release, and that could lead to your sales team having missed promises. And when they miss promises, you're losing sales and damaging your reputation and your brand. And when you look at it that way, there's more cost to having a dev environment that's down. If your pipeline is broken because of an environment being down, you're missing out on a whole lot of things. So let's take a look at a traditional pipeline. What I've seen, for the last number of years of, usually small, medium business, and even sometimes in the corporate space as well. We've got a developer that's assigned some task. They create a branch for their task. They write their code. They create a feature, a pull request. The code starts to get built. This might happen before they, make a pull request, but this is a simplified version. Unit tests are ran. The status of those unit tests are reported to the pull request. You have somebody else review the code. Let's say it looks good. They merge it. Then it gets deployed to dev. You have your unit or your integration testing deployed to test. You might have QA test it, and then finally it's pushed out to prod. So what if we had multiple tasks that are trying to be integration tested at the same time? If we do them in a linear fashion, we have test 1 deployed to dev, integration test run, while you've got task 2 and task 3 that are still waiting. Let's say that integration test passed, task 1 is good, it keeps going down the pipeline. Task 2 is deployed, and the integration tests are ran. What if it fails? What happens to task 3? Task 3 is still sitting around waiting to test. We're then blocking other developers in their ability to move forward. They may be able to jump on another task and continue working. However, they have to then context switch back to their old task to make sure that the integration test passed. All right, well, what if we just batch them all up and then deploy a number of things to our dev environment? Well, that often happens. We have a dumpster fire. And what that means is now we have to play detective and go and figure out which one of those tasks, what portion of that code was actually the issue, and then either cherry pick around it or revert entirely and then fix that and then merge again, we're slowing down our productivity here. And what we want to do is make that quicker and more efficient. So how can we prevent this? We need to make our non-prod environments more efficient. So what we can do is we can automate our rollbacks. Well, that takes time. Hopefully, you know, if bad code goes out, we can roll that back, but it still takes time. It's still, you know, prod or your non-prod environment still has to roll back. It's down for minutes. If we're adding on minutes, then we're, you know, slowly growing back to that number that we were talking about initially. We can shift further left. So we want to test our deployments before our code merge, and we'll talk about that here shortly. And if we can, we want to treat our non-prod environments as cattle. And this is where things kind of get interesting, especially, you know, we've had the cloud for quite a while, and this whole time I've been building to this idea where, you know, we talked about, you know, using our servers as cattle when we talked about auto scaling and things like that. But now let's take it a little bit further and make entire environments as cattle. That way we can, you know, build them up, blow them away, drop dev on the weekends because nobody's using it, you know, stuff like that. So we want to enable each release to have its own temporary environment and take that shift left and provide it basically its own environment. And then if we have any like, you know, long-term, you know, sacred environments, if they're broken and, you know, we spend more than an hour trying to figure it out, let's rebuild it. Something must have happened, right? If we can just rebuild that without, you know, having to spend a bunch of time to revert whatever happened, it's usually the quicker route to get people back to work. So let's take a look at a diagram with that in mind. I skipped the top part because we all understand that. Let's talk about after the pull request is created. So you create a pull request, and again, this can happen before a pull request is created. We can do this off the feature branch itself. It really doesn't matter. But let's run our unit test, and then let's test the deployment. So we build up a feature environment based on this piece of code. And then we actually do our integration testing there so that the status report to your pull request actually contains the unit test passed and the integration test passed. That means the person reviewing the code isn't really looking at it for, hey, do I think this is going to work? But more so along the lines of, is this secure? Does this follow our style? Does this follow our normal practices? Do I think the architecture of what's being built is correct? Rather than stepping through it and saying, is this syntactically correct? I mean, obviously it's syntactically correct, but you know, in that form, they're basically doing the work twice by having to step through the code and think about it. So if you can take that off their back and say this actually passed its integration tests before it came to you, then they're spending less time on that code review, but doing more quality work, doing what's important. Once it's merged, we create a version, and we'll talk about that a little bit later in the slides. And then we package it. And then that package can be used to be deployed to any number of environments. So let's say QA wants their, QA needs their own environment to run their, you know, whatever test, the Selenium test, etc. Maybe a QA member wants their own environment. They can build that up and use that package to test that specific version. If you've got customers that want to be able to test against you, but you don't want them interfering with other customers and say like a shared UAT environment, you can then build their own with this environment, this cattle idea. And then you can charge them back if you want to. And then lastly, you know, your package will eventually make it out to your prod environment. And the ability to kind of drive this and rely on that package being good comes from being able to test it in a before it's merged. And I mean fully test it with integration tests. So where do we start? First, versioning, and then our infrastructure management. Then we'll move to configuration management, and then our database management. And all these things together will provide us a good path to being able to boot an environment without caring about what the name of it is. It could be Derek's Environment 5. I shouldn't care. I should be able to boot that up and tear it down as needed. So versioning, right? You have to version everything. And this goes for the operations team too, especially the operations team, because when we were talking about those version contracts, that version contract also brings in your infrastructure, right? And your configuration and your database. I highly recommend semantic versioning because we know what's changing. I've seen a lot of different versioning strategies. Going off build numbers is, interesting, but semantic versioning will tell me what changed. I've seen a lot of my repositories will have our minor version be extremely high, in the hundreds. But that's because we're constantly making changes, adding new features, building up the environment. So it's okay that number keeps revising, but it's the best versioning strategy I've found so far. You have to establish API contracts, the version contracts, right? If you're not changing the major version, it should be reverse compatible at all times. If you're not reverse compatible, then you need to change that major version, and it needs to be communicated across absolutely every team. If you're building infrastructure that allows developers to self-service and they're relying on your library as a specific version, they should be able to upgrade and their code should still run on that as long as you don't rev that major version. And lastly, never rebuild a version. It's I think that's kind of an obvious one, but the reason I bring that up is because after code is, if we're looking at more of a if we tag our branches to environments and then we rebuild that code at that point, there are things that can slip in. If you've got a strictly defined branching strategy, it's less of an issue, but I've seen it happen. So just make sure you're never rebuilding the code after you package it the first time. So let's talk about our infrastructure management. There's a lot of technologies here that can really help us out. Terraform for one, I put that at the top because it's cross-cloud, or at least it's syntactically cross-cloud, and it works like a charm. CloudFormation is really my favorite. I threw CDK in here after Randall's talk because although I only caught a little bit of it, I saw that portion about the abstracted objects, and it was really something interesting. In Azure, you've got your ARM templates and so on. And then even in the Kubernetes world, you got Helm, which kind of defines the infrastructure for a service on top of Kubernetes. So I would consider Helm templates as infrastructure. So you want to have your environments completely modeled, right? I need to be able to, make one call to completely pull up an environment, or at least that's what I aim for. So you got your app servers or your containers, your data stores, your proxies, your load balancers, and even down to the DNS. All of this completely modeled and automated and templated in a way that you can change the name of that environment and produce an isolated environment for testing, for whatever may be needed. Maybe even demos. Your salespeople need to be able to demo the product. You don't have to leave your demo up all the time. Throw up a new one, a half hour before the meeting. If you version everything and you treat your infrastructure as and environments as cattle all the time, you can rely on that, and you'll feel the safety of being able to do that. Configuration management. So your Ansible, your Chef, SaltStack, you know, these tools, if you're still building servers, they're absolutely necessary. And in this world, I don't think that everything should be Dockerized. It can, but there's still some old stuff out there that just doesn't make sense to run it in Docker. So you're still building servers with these technologies. Versioning this is it will become important because you'll have configuration changes that you need to template out per environment that maybe may need to go along with a certain version of the application. Docker, I think the Docker file fits into configuration management. It's typically versioned along with the application code itself, which is awesome. It really makes things a whole lot easier. But it's still that layer of what we're talking about here. So configuration management is used to install, configure, and template out our dependencies, our applications, our connection strings, and any configuration files that may be necessary. And we use this typically based on, things in this portion change based on the environment, right? You may be adding more heap space to some servers in prod rather than dev because you're running smaller servers, things like that. But those should be all those things should be templated so that whatever environment you're running in, we're able to modify those to the needs. Database management this one's hard, but it's absolutely necessary. So we've got a lot of tools out there. The ones that are kind of, come to mind right offhand is Liquidbase. It works across lots and lots of different databases. It's got an XML format, and you can give it raw SQL to run. And we're basically just, versioning the schema migration that we made it into. And that schema migration might not just be the schema. We can actually, do DML changes as well. And we can have ways that, those long-running DML changes won't block the deployment, but maybe we'll do the schema change and we'll, run those after the fact. Flyway is a big one for the Java community. It's got it'll map to your Hibernate classes and just do most of the stuff, do the migration for you, so you don't have to write raw SQL. That's pretty cool. Alembic is more for the Python community. Allows you to, Flyway is, like I said, kind of Java. Alembic, more for Python. Both of them allow you to do the work in, the language that it's built in, so that you're using objects rather than raw SQL, if that's what you're looking for. I'm not sure, but I think Alembic plugs into SQL Alchemy as well, so I can read those classes, those models. When we're working with environments as cattle, when we build up an environment, we need some sort of data. There's a lot of data for applications that needs to kind of just be there for bootstrapping. So with database management and your schema and your actual bootstrapping data versioned, you can actually just load in a bunch of data, which your QA testers may need to even get started. And then we've got snapshotting, right? Your dev and QA data is important. A lot of it will come from that default load, but sometimes QA members may need some of their data to stick around. So we can build from snapshots as long as our infrastructure code is ready for that. But it's also important to take snapshots upon decommissioning of key environments. We had this setup one time where we would snapshot an RDS database before killing developer environments, so that when the developer came back on Saturday, or not Saturday, after the weekend, they could come back reboot from that, automatically reboot from their latest snapshot for their environment. And it was like they just turned on and off the environment rather than losing their data. So with those three things, we've got a version on each of them, right? Now this deployable release thing here at the top is kind of a manifest of all three of these things. We need to say that with a version, with a contract, that a certain version of the infrastructure will work with a certain version of configuration to be able to provide the application at a certain version. Sorry. And then all of those come up to what I call a release. I think language is really important when you're kind of talking in these technical ways. So when I say release, I'm talking about the whole manifest of all the things together and knowing that those all work together. And with that, with knowing these three versions, I can reliably deploy to prod saying this release was tested thoroughly and we can deploy with confidence. Your infrastructure templates are going to take things like your configuration version and your application version and your connection strings and pass those to your configuration templates. Well, your configuration version is the configuration template you're passing it to, but it needs to know what application version to pull. Maybe you're using something like S3 or Artifactory with all these application versions. We're going to pass that all the way down from the infrastructure into the configuration for it to pull that application. So the way I see it, infrastructure, when we build a portion of infrastructure, we're driving the entire thing from this one infrastructure template, saying, parameterizing it, saying, give me configuration version X and application version X, and we're running a certain version of our infrastructure. Configuration will template out the application with its connection strings, and it'll be ready to rock and roll. So to diagram that out a little bit, the way CloudFormation and Terraform, stuff like this works, is that it'll actually build a dependency tree. So when we're building things, what gets built first are, our caches, our data stores, queues, and things like proxies. And what happens is our services come in and our infrastructure is actually going to feed all of the endpoints of these different data stores and things like that, even the proxy, to the configuration code. Because they need to know how to connect to these things. And it's kind of a thinking backwards that the proxy needs to, or the REST interface needs to know what the proxy or load balancer is, but it's the one that's registering with that proxy is saying, hey, you can now pass me traffic. So with that, we've enabled a few opportunities, right? Developer environments. This can get costly, but sometimes if a developer is making a big, scary change, it's really important for them to be able to test it out before, even just while they're building it. They might want to test before they get too far into the development. So giving them the ability to build an environment from version X and then upgrade it to version Y makes them feel more confident that once they do push it out, that it's going to be good. And it gives them the confidence to continue going along the path. Maybe they're making it, prototyping something just to see if it'll work. Feature branch environments. This allows us to shift left and build things out and test them and do our integration testing before we have anybody review it. Extremely, extremely valuable. This is what's enabling us to, have something in dev or QA that we can rely upon. We can provide our customers with their own environments. If you're a SaaS organization that has single tenant environments, and this is probably something that you were thinking about long ago, and you're probably already doing this. But again, that sometimes I've seen customers demand their own QA environment, and organizations just not know where to start, because sometimes environments take a long time to build. especially if you don't have all this automation. We're able to shut down non-prod during the off hours, right? So if you think about it, your devs test stage environments, if you're using these sacred environments, they're probably costing quite a bit. And if we're able to shut them down from 9 to 5, as in 9 at night to 5 in the morning, when most people aren't working, and then again on the weekends, we can do that. Saves a ton of cloud costs. We can test the deployment, not just the code. Again, this is super important, right? So the CI/CD process is, we've made such an investment in it already. Let's continue making that investment so that we can test that process before deploying it to the main line. I mean, how many times have I seen the CI/CD process stop all productivity because nobody can get their code out, there's nothing's building, so on and so forth. We can validate with that. We can validate our schema migrations. Big schema migrations are scary, right? And if we don't have an accurate amount, if we don't have a prod-like database to be able to test those migrations on, we don't know how long that migration might take. And that could really, make a scary prod deployment. And we can validate our uptime during those deployments, right? Are we doing blue-green? Is it effective? Does the code that does the blue-green work appropriately? Are we up 100% of the time while we migrate from one version to another? Or is there, a drop packet? Did we reset a connection? Things like that. And then lastly, we can re-provision these broken environments, right? If dev was down for 8 hours a week, and we could just and something is just terribly broken, somebody's rogue and they, went into the server and they keep changing something that completely breaks it, and we can just re-provision them. That also gives us the ability to say, there's no reason for you to need to be in any of those other environments. And that leads back to something that we've been working on quite a bit, is compliance. I've had engineers ask me, can I get access to the dev environment? And I ask them why. Logs are streaming. We can, you can build your own environment to test things out if you need to. But these environments, they're used for specific things, and we need to keep them clean. So by going through this exercise and doing the work to onboard a company to this sort of thing, we help them take building an environment from 8 weeks with 2 FTEs down to a 30-minute Jenkins job. That's a big difference in work time, right? And they were the type of company that was building environments for their customers because some of their customers didn't want to be on the SaaS platform. They wanted their own SaaS platform, their own installation, right? So we help them make that much more productive and drop that effort 1,280 times. It's just it was an insane figure to look at. So I just wanted to put that out there. And just to close up, tips on making this stuff easier: automate everything, version everything, fetch your configs from environment variables. So much easier to use than templating things out. And if not, fail back on your config files. That's something that I've found was the easiest for transitioning. When we come into an organization and say, oh, we want to move all of the connection strings to environment variables, but we're building a new environment for them, and we're kind of doing our stuff in dev, right? We're kind of doing our dev work on infrastructure and configuration, but they still have prod to their own, dev environments and prod and stuff like that to support. So what we found is, like, if you make the change in the code that says, look for environment variables for this stuff first, and then if that environment variable doesn't exist, fall back to the config file, that has been extremely helpful in making sure that we can move our work forward in the right way, but also allow them to do their work and not have to make the same changes that we're making to our environment in theirs, which would defeat the purpose. Never depend on an environment name. This is super important, right? Because these are now cattle. If you're doing any switching in any of your code, even either infrastructure or, you know, configuration code, if you're doing any switching based on the environment name, look for a way to get that out of there. Find a different place for that. And lastly, decouple all you can. But when you decouple, make sure that you have those version contracts. And that's all I've got. So thanks.
Thanks so much, Derek. So we've got a little bit of extra time here. If anyone has any questions, can you either place those in the chat or raise your hand, and we'll make sure that Derek has an opportunity to answer those. There's no shyness at Community Day, so get those questions out there. All right, Derek, that's always a sign of a job well done. So Derek DeJonghe, and I apologize for the mispronunciation earlier, we appreciate your talk. And if everyone is interested in our next talk, that will be starting at 12:30. And again, a reminder, this is track 1. So we'll be back shortly at 12:30. Thanks, everyone, and thanks, Derek.
Yep, I'll be on Slack.